All right. Just a quick check that you can see my slides. All right.
Yes, we can all see them.
So like I mentioned, I want to talk today about building effective agents with MCP. I think the topic today is about tools, and I think really agents are a more advanced form of tool calling with LLMs, and I think MCP plays a pivotal role in building all of this in a reliable and effective tech stack. And so I want to cover very briefly what like the agent tech stack looks like today, given some of the recent developments. I want to talk a little bit about advanced MCP patterns. So far, we've seen a lot of MCP servers out there that are, kind of one-to-one mappings of existing REST API services. But I think things are getting more advanced. And in fact, servers can be agents themselves. And I'll show you a few examples of that. And lastly, I want to talk about like agents as cognitive workflows that can be long-running asynchronous workflow tasks and what that means for kind of like agent architecture and some of the assumptions that we have so far as we build agents and kind of like what breaks as we talk about these more advanced workflows. And so a quick thing about me, I'm the CEO of LastMile AI. And back in the day, like this is circa 2018, I was working on language server protocol servers back at Microsoft. And LSP, for those who are not familiar, kind of revolutionized how IDEs are built, because before this, there was like all sorts of different ways for every single IDE on how they connect to kind of language features from different languages. And so you never really had great language servers that worked across different clients. And LSP kind of standardized the client server contract. And now today, if you look at it, there's like hundreds and hundreds of LSP implementations out there. And almost any modern IDE client implements language server protocol. And I've been thinking about LSP style protocol for LLMs for a long time. This is back from Jan 2023, before LLMs could even make tool calls. The ChatGPT plugins was like about to come out, and I was thinking about like how should we standardize the interaction pattern between LLMs and kind of the world around them, which includes tools, data, resources, etc. And so suffice it to say that like as MCP came out, I got super excited and got looking into it right away. So a quick thing about agent tech stack in 2025. I think the main things that are changing now have to do with three different paradigm shifts that are all converging at the same time. The first one is models have gotten really good. And the result of that, especially with reasoning moving into the inference layer, is that a lot of complex kind of application patterns that existed before, like React or chain of thought, are now actually happening when you call the model inference API. So you can trust that the models will do more than they did before, and they'll do a better job of it. The second part is model context protocol, which has started to standardize how LLMs connect to tools and data in a systematic way. And this is now providing a single way for us to give context to LLMs. And so like that completely changes how applications get built, because you don't have to build for specific service providers anymore. And the last part of that is that like the result of both of these things is a much simpler application architecture for agent developers. And you don't really need monolithic AI frameworks anymore, the way maybe like the V1 era of LLM development looked like. You can get a lot done with simple agent patterns that are enabled with MCP and really powerful models. And there was a post by Anthropic around the same time that MCP came out called Building Effective Agents, which kind of introduced these very simple patterns that worked well in production. And the simplest one is, connecting to an LLM to tools and resources and letting it run in a loop and making it like decide if it needs to call a tool, if it needs to fetch some data, and kind of like do that until the original objective is satisfied. This is never truly enough in like complex workflows, but it does get surprisingly far. Then there's like the evaluator optimizer pattern, where one LLM kind of generates a response, and then another one evaluates its quality, and you run this in a loop, basically passing data from one LLM to the other until you're satisfied with the quality of the response, and then you return the response to the user. And you can keep going more complex. So the orchestrator, this was like an early iteration of what today is now deep research, or kind of like multi-stage kind of workflows, where you have a lead planner that decides how to split up tasks into subtasks, and then each of those subtasks gets orchestrated. And each of these subtasks also has access to tools and data through an MCP, and then you synthesize all of that and send the final response back to the user. And architecturally, these are like very familiar to folks. And so what I started doing at the start of the year actually was combining these basic patterns of building agents with model context protocol. And that's what MCP-Agent is, which is this open source library that you can like kind of use to build agents in a very simple way, just relying on MCP as the way you connect LLMs to context and letting like the rest be just a set of simple workflow patterns to do the job. And so there are a few observations that result from that. One is MCP is going to be everywhere, right? Like every line of business application is going to soon become an MCP client. So think like Notion, Google Docs, etc. And every service is going to have an MCP server that corresponds to it to give an AI native surface to LLMs to interact with it. And what follows from that is that like agents should then also be exposed as MCP servers because they're effectively like treated as microservices. And if you deploy them as MCP servers themselves, then you can integrate those agents, your custom agents, into any MCP client, which based on the previous statement is going to be like any line of business application. And finally, agents are also async workflows. And what we believe is they should be modeled like traditional workflow jobs because some of them can take a long time. They may pause, resume, and I'll talk a little bit about that in a sec. But those three things, I think, fundamentally change how we think about building agents in the world of MCP. By the way, this logo over here, this is our mascot called Fetch, which is kind of like the representative of MCP agents. So you'll see this scattered around everywhere in the slides. So the first thing I want to talk about is agents as MCP servers. If you think about like agentic behavior today, almost all of it happens on the client side, right? So you use Claude Code or you use Cursor and you connect them to MCP servers and then they solve tasks on your behalf. And so the agent in that case is actually like Claude or Cursor on the client side. But what if agents themselves were exposed as MCP servers? Then you could do like any MCP client could connect to agents over MCP. The agents are exposed as a series of tools. And you can have the MCP client basically coordinate and orchestrate agents the same way that it coordinates and orchestrates MCP servers. And so what that means is you can actually do like very sophisticated, even like multi-agent interactions using just MCP, because a client could call like an agent server that's over MCP, which in turn may be connected to other MCP servers, and it's acting like a client to those servers. And so you basically can get this network of multi-agent collaboration happening over a very simple protocol. And I'll give a very quick example of this where I have this like basic agent server, as the name suggests, and you can see that it's basically like you define an MCP app. You even have like fast MCP setup. So it's just as like very familiar to people defining tools and whatnot. But you also have these workflows, which under the hoods become tool calls in MCP-Agent. And this agent just does something very basic. It like, connects to this Finder agent. It has access to the file system and the internet. And then you can like basically connect to it in Claude Desktop. And here you'll see the basic agent server. It exposes a couple of tools and you could like run them. And you can run that agent as workflows. So you can do like workflows run, workflows get status, resume, cancel, etc. And then you can like actually here there's an interaction where it ran a workflow and then it kind of goes through and there's an agent on the client side, like in Claude, that's interacting with my custom agent. And then also the agent is on the server side, which is like this kind of multi-agent orchestration happening and a communication happening across MCP. And in this case, it like kind of ran the workflow. I asked it, what's the result from basic agent? It does get status. It returns the result. In this case, I just asked it to like create a tweet. So a very simple agent. And then I asked it like, how much did this workflow cost? And it calls the get token usage tool. And it returns like the tokens. It returns what models were used, etc. And so you can like basically build agents as MCP servers. And then this is Claude Desktop, but I could very easily use the same agent that I built in any other MCP client, which is the cool part. And so what that enables you to do is have composability because you can model multi-agent interactions over MCP. It gives you platform-agnostic agents because agents are no longer bound to the client. And then it also lets you scale them out because the infrastructure can actually be like server-side. The second part that follows from this, like let's get more advanced, is async workflows being used to model agents. So agents can be paused and resumed. They need to wait for human feedback. They may fail and need to be retried. They can be triggered or scheduled, like a cron job, and they may take like hours, maybe in the future even days to run. And all of that really is like an asynchronous workflow. And so an MCP agent, what we do is we model this as using Temporal. So you basically schedule tasks, and from the user's perspective, they're just interacting with it as an MCP server. But the orchestration and execution of that is happening on a proper workflow orchestrator that can be paused, resumed, retried. It can like basically get human feedback and continue. And it can basically like run for hours, days. It's kind of indefinite, in fact, like how some of these orchestration engines work. So a very quick thing, you can actually like build a deep research agent using some of this. So I'll do a quick example, and we're going to publish a blog post on this later as well. So here I have this an MCP agent. I implemented a deep orchestrator, which is basically a way of enabling deep research style architecture, but using MCP as the way of communicating. So here I have given it access to the fetch and file system servers. And in this case, I wanted to like kind of do finance deep research. So here, I think my system prompt here was, I wanted to do research on the Meta stock, and I wanted to gather historical financials for the last 3 fiscal years, do a bunch of analysis. I even gave it some like sources of information to like look from. But I never told it, like, I never connected it to the internet. I never tell it, like, the output, by the way, is going to be an Excel sheet, but I never tell it how to use Excel. All of that is modeled over MCP. This is just like, and I just specify the MCP servers. They're defined in my config. So I have the spawn settings all set up here. They could be remote. They could be running on standard IO. And I can even give a budget. Like I want to say the maximum amount of tokens you can use is 200,000. It should cost a max of $3, and you can run for 15 minutes. And then you can just run this. And because we don't have 15 minutes, I'll just show you a video of what this looks like. And so this will be familiar to folks who've like used Claude Code or something, you know. It sets up a task queue. It breaks down the work into subtasks. It goes about executing them. Each of these tasks is like dynamically generated by the deep research agent to figure out like how, which tools should it have access to, which servers should it have access to perform its job. It extracts knowledge from like completing the tasks and accumulates that in its memory store, and then passes that knowledge to the relevant future tasks to be able to like complete their job. And so this runs for a while. You can kind of see the tokens being updated as the usage is continuing, the tasks being completed. So it's very much like deep research. And as you can see, this is like an async workflow. And right now there is no human input involved, but you can very easily imagine like one of these steps may pause for feedback. And that's why we think this should be an asynchronous workflow. And then like once this finishes, you kind of get a report from, I'll give a like very quick thing. I asked it for the last 3 fiscal years, so it did that. And it does quite a great job of like just giving me high level metrics. Styling is a little off, but that's like due to the style, like the quality of the specific MCP server I'm using for outputting to Excel. But I want to stress that like the architecture of the agent had nothing to do with teaching it how to use any of these tools. It just knows how to use MCP and is able to do like query the internet, make tool calls to create Excel files and all that, all through MCP. And so very quickly, like there are a few advanced things that MCP does need in order to make agents really work well. One is elicitation, which has already started to become part of the protocol spec, which is basically this idea for a server to initiate a request from a client, which can be used to model like human in the loop kind of workflows. You can also use elicitation. This one's actually like a proposal in the spec right now, where as like in an agent server, you may be connected to like Slack and GitHub and other like external services through MCP, and each of them may need authentication. So you can elicit like an auth request for a downstream server using the same like elicitation API. And what I showed about deep research, what you're starting to see in terms of agent architectures is like there's this lead planner that kind of like does the planning and orchestration, breaks tasks down and gives them to sub-agents. All of this is like facilitated through MCP. And a lot of this is long running and durable workflow. So like they're failure resistant and kind of are able to run for a long time with human in the loop. Some of the concrete recommendations I want to end with. One is, I think MCP is all you need. I really believe that. And I think MCP can actually evolve to facilitate like agent interactions much more effectively, but it can already be done as I demonstrated with like the tools and the spec as it exists. Second is using workflow orchestration to model agents, such as like Temporal or some other kind of orchestration engine. It's really important to have like production grade, enterprise ready like agents that really work. And also starting with simple workflow patterns, really important. Unless you need more complexity, like don't start with that. Keeping humans in the loop is really important. I don't think like full autonomous agents are really like robust and reliable just yet, and maybe not be for a long time. But like getting the interaction model right, where the human is always in the loop, is really critical. And the last part is like setting up evals for MCP servers. We often talk about evals for like agents or your like LLM applications, but we should also start thinking about evals for the servers because they're used in agentic environments, and the quality of the server really affects the quality of your like end application. There are lots of problems to be solved. We're solving some of them, but like, you can imagine long-running tools. How do you authenticate and authorize those actions for agents? How do you manage context? Tools, like we're starting to hear that some servers have like 10,000 tools. So you can't obviously give all of those to an LLM. So how do you like manage all of that? There are a lot of like really challenging things here, but I'm pretty hopeful that the protocol can like evolve to cover some of this. And so, yeah, lastly, like just thank you for having me. And I also wanted to stress, check out MCP-Agent. We're actively developing it and would love your feedback. And if you are interested in solving any of these problems, we'd love to collaborate with you. Thank you.
Thanks so much, Sarmad. That's really it's really interesting. It's something we've been having there was a couple talks about this the last Dev Summit as people were talking about MCP as agents. And it's interesting when you sort of break down the elements that you see an MCP agent needing. It seemed like workflows and orchestrator were pretty fundamental ones, like as the two. But one of the things that I keep looking for when I envision this MCP agent too is like a lot of it is like the system prompt. Like, where is the system prompt in your system? I didn't quite see that. Maybe I missed it. But like, how do I define, like, if I go out and I'm talking to the MCP agent for United Airlines, like the first thing I'm really hoping is that thing is actually, feels like a customer service agent, right? It knows what its role is, its identity is. I'm mounting it to my chat client, right? Siri or whatever I'm using in the future to talk to these things. But I really want the identity there. Is that also in there? I probably missed it, but how do you sort of define that agent system prompt?
Yeah, that's a super important point that you brought up, Shannon, that like prompting is really important in this world to get the agent behavior just right. So it's all managed within these patterns. Like we allow you to customize the system instructions. I actually think system prompts in MCP currently like prompts are modeled for user app driven behavior. So like you can do get prompt from an MCP server to get like standard prompts. I think in the case of agents, I would actually argue some agent servers can ship with like high quality system prompts as well that may actually be passed into the agent tools when you kind of like use it. That part is like unclear, but at least in MCP agent, you're able to like model it and define it. And the key part is the architecture, which is like, how do you set up an orchestrator or how do you set up these agent patterns is kind of separate from what is the prompt and what are the MCP servers you use. So you can kind of plug and play these pieces and make it really custom. The deep orchestrator has like tons of custom logic around how to manage task queues and memory and all that stuff. But like the finance agent that I just mentioned, most of that code is like it's 200 lines and most of it is UI to display it in the CLI. Like the prompting is the major part that's like you have to customize. So you're totally right. Prompts are really critical and you should like really customize it to make it work well.
Yeah, I think one of the bigger questions I have, because I talk to a lot of people about this, like MCP agents, because like I'm so invested in this idea that basically agents should be MCP servers. But there's kind of this basic question. I'm kind of curious what you think the answer is like, it's kind of like, what is an agent? I know you can't answer that, but like if you look at it from the perspective of like an MCP server has tools, and those tools can do whatever the heck they want. So if it's code or it's agentic, it doesn't really matter. It's just a tool. So then when you say, well, what does an MCP agent need of the protocol, or what defines what an agent is? Like, is there something unique about the interaction pattern or something? The only thing I ever get from people, and I have a different perspective I can share, but like the only thing I ever get from people is really like they want asynchronous tool calling. So it's kind of like, it kind of boils down to this like kind of very weird conclusion of like, there's nothing special about an agent. Is that true? is an agent just an asynchronous tool call, right?
It's a very good question. Yeah, my take is actually like I think an agent is in the modern definition is a component that uses other tools in non-deterministic ways. So like it's connected to MCP servers, and so the tool that like the agent server is actually like acting as a client to other MCP servers that it's using to like when you invoke that server, that agent's tool. And so that part is, to me, like the non-determinism is inherent in what is an agent. If it doesn't even use an LLM, that is, I would say it's like probably not an agent. And if it does use an LLM but doesn't make tool calls, then it's like also arguable, like where's the boundary? But in some ways, it's also not as important as this idea that like, you know, the GitHub MCP server, it's open source, it's a really good like overall implementation, but I would love for GitHub to have tools that do more like arbitrary things for me instead of just like map to their API. So like I'd love to, you know, fork a repo and then create a PR and submit this GitHub action all in like one tool call where I could like kind of prompt it in this non-deterministic way. That to me is like it defines agent, but you're right, like there's no definition for it that I could give you.
But it's like, so it's the thing from like a protocol perspective, because it's like, you know, like, because there's like A to A is its whole protocol, right?
Yeah.
But they're like, well, what does MCP need to be able to do agents? And like the only answer I'm getting from anyone is asynchronous tools. And like maybe that's just the answer. That's the thing, as I think is interesting, is like, is that really just, is that the answer? Is like, is there really nothing special? That like agent is more of an implementation detail. So I will throw out like my counterpoint to this or whatever, is what I think the MCP lacks in terms of agents is when people talk about agents, they're always talking about agent to agent. And everyone's looking at agents talking to agents. What is fundamentally not possible, if you assume that MCP is an agent, it fundamentally does not work with human to agent. There's no way for a human to talk to an agent, because today, MCP is modeled as fundamentally the idea is you first go to an LLM, then you go to MCP. But like what Shannon was pointing to, like what he was kind of saying, is like he wants to control the prompt, not like I'll give you a prompt and you put it inside of the prompt, but like you can't give a prompt to Claude that says you're not Claude anymore, you're now Bob. You're like you can't, because it's a safety issue, right? Like it just doesn't make sense. Claude can't do that. So when I look at this of like, what is an MCP agent, is I actually look at this like, what does it mean for a human to actually, because like, I think if you figure out the human to agent interface, it degrades very nicely to an agent to agent interface. So async is part of it, but like, so this is like my own pet project. And so like, anyways, I don't want to like, this is your form, but anyways, so that's what I throw out to the world is like, I think for us to really define what an agent is we have to consider the human to agent interface and what that looks like, and that needs to be standardized. Then that makes it very clear on what is different between an agent and a tool. But anyways, that's my
I completely agree. And at least right now, the way it's modeled in MCP, like the closest part of MCP to the human is the MCP client. And I would argue we spend a lot of time talking about MCP servers and too little time talking about MCP clients. And that like, so for example, there's no good MCP client today that like models all of MCP's capabilities. Like I wanted to show notifications and like long running tool calls. They show up in like the VS Code Insider's like logs pane, but not in the agent view. And then elicitation, like how should the agent how should like the human interaction with the agent work for these, even the existing parts of the protocol are kind of not fleshed out on the client side. And I would actually, like my recommendation to folks who are like getting into MCP is really think about the clients, because that's where I think a lot of the interaction model needs to be like really thought through a little bit more.
So this is something I've been personally working. I have this pet project I've been doing that I'll announce for some time, but it's like, it's kind of a, you know, like, because I had that same opinion that like the clients aren't good enough, but there's this kind of dynamic where like, the clients are always attached to something else. Like Goose is a good example of like a very independent, like they're not attached to anything else. And they're kind of just like, so they're the kind of the, I would say probably the best positioned right now to just build something that's great for MCP, but everyone else is attached to something else. Like like, you know, they have some other business objective or whatever. So like I set out of like, hey, let me just build like the best MCP client. And it has been an interesting exercise because, to be perfectly honest, it's not that easy. It's like there's a lot to the protocol, and when you start thinking about all of the like, oh, let me really enhance, like really support every different thing, you're like, wow, there's a lot to this. So it's interesting because like I would love to see anyone else, because like I only have so much time, but this is something I've been fooling around with. Is like, yeah, this client space is like there's
a lot there.
There's a lot,
guys.
there.
We need to keep moving. It was great having you, Sarmad. Thank you so much for sharing all this. Congratulations on the project. It looks really interesting and really cool.
Thank you so much.
Yeah, I'd love to follow up with you on
maybe stick around. We'll chat a little bit after we're wrapped up.
Perfect.